Now we're going to be using what you know about rational expressions to solve equations containing rational expressions. So I know I've got this when I can solve equations containing rational expressions and solve equations containing rational expressions for a specified variable. Rational expressions, solve rational equations. So you're going to multiply all the terms in the rational expression by the least common denominator to eliminate all the fractions. Combine like terms and solve for the variable. So first note that an equation contains an equal sign and an expression does not. A lot of times students use those two terms interchangeably. An equal sign means it's an equation, an expression does not. Solve an equation containing rational expressions. Again, multiply both sides of the equation by the least common denominator of all rational expressions, remove any grouping symbols and solve the resulting equation and then check it. All right, so in this equation, we have 3x and 6 in the denominator. What would be the least common denominator? We need a 6 and an x, because 6 is the least common denominator of 3 and 6. And then we also have the x. So what I'm going to do is I'm going to multiply the entire thing by every term in here by the 6x. That's an equal sign, equals 6x times 7 over 6. Now, you don't have to write it out like this each time, but I'll show you in the next one how I normally do it, but this is a good beginning, okay? So we're going to multiply the 6x by everything and then solve. So 3x and 6x can be simplified to 2. So 2 times 5 is 10. 1 times 6x is 6x. And then this 6 and this 6 can cancel each other out, so you would just get 7x. So now I'm just going to solve the equation like normal. Now we get 10 equals x. Now, rational equations, you do have to check your answers for extraneous solutions to make sure that the denominators don't equal 0, but in this case, it does not. So 10 is fine. All right, 1b, we have 1 over 2x minus 1 over x plus 1 equals 1 over 3x squared plus 3x. I need to factor this denominator. So I'm going to pull out the GCF, which is 3x, and I'd be left with x plus 1. Now you can see what the least common denominator of everything is. So we are going to multiply this whole thing. Remember, this is replaced. So 2x and 3x, the least common denominator would be a 6x. And then you've also got the x plus 1. So 6x times x plus 1 would be our least common denominator. So if I'm going to multiply everything in the top by 6x times x plus 1, I would have all of these are 1s in the top. So it would just be 1 times everything. So 1 times that. And then 1 times that again. And now we're going to simplify, okay? So we can simplify the 2x and the 6x, and that would be a 3, right? Because 2x can go into 6x 3 times. My x plus 1s would cancel out here and here. And then the 3x, that could be changed to a 2. So let's write what's left and distribute. So 3 times x plus 1 minus 6x equals 2. That's all I have left after all that factoring and simplifying. So distribute 3x plus 3 minus 6x equals 2. Combine like terms, I would get negative 3x plus 3 equals 2. Subtract the 3, and I would get negative 3x equals negative 1. Divide the negative 3, and I would get x equals 1/3. Okay, now you get to do one. So try that. And I get -7/5 as my answer. Number 2A, I'm going to do this one. So again, there's two ways that you can actually do this problem. Since you only have one monomial on either side, one term on either side, you can cross multiply. So you can say 2x minus 2 equals 1x plus 1, and then just solve. That's the easiest way, honestly. So you get +2 + 2, so you get x equals 3. And you have to make sure that that's not going to make your denominators equal to 0. So that's going to work. Okay, now that is the answer. But I want to show you the real way of doing it because that's too easy of a problem and it's not going to prepare you for the next one. Okay, so let's do this. The least common denominator is x minus 1 times x plus 1, right? Okay, so this x minus 1 would cross out. So like, watch, we're going to say x minus 1 times x plus 1 over the x minus 1 equals 2 times x minus 1, x plus 1 over the x plus 1. So this would cancel, and I would just be left with x plus 1 equals 2x minus 2, and then solve. So subtract the x and add the 2. So I get 3 equals x. Okay, next. See, this is what I was talking about. You can't cross multiply like that unless you just have one term on either side. So let's go ahead and factor this first one. So we would have 3 minus a and 3 plus a. So the common denominator for everything would be 1 3 minus a and another 3 plus a. All right, now if I multiplied this first term times my least common denominator, the denominator and the least common denominator would cancel each other out and I would just get 12. And the next one, the 3 plus a's would cancel out and all I would have left is the 3 minus a. And the third term, the 3 minus a's would cancel out and all I would have left is the 3 plus a. So now you just combine like terms, you distribute and combine. So I'm going to add 3a to this side, and I'm going to subtract 6 from both sides. So I would get 15 equals 5a, divide by 5, and I would get a equals 3. However, if you look back at the original problem right here, if I have an answer as 3 and I plug it in there, that denominator is going to be undefined. It's going to be 0 and it's going to be undefined. So this problem has no solution. You can't say a equals 3 is an answer because it's an extraneous solution. All right, let's do another one. What is the common denominator? Well, actually, this one says solve for x. We're going to solve this. Okay, so the second success criteria for this lesson was solve for an indicated variable. Okay, so we are not solving this equation. We're just isolating x. Okay, so how do we do that? All right, what is our least common denominator? Well, we have an a, a b, and an x. So if I multiplied each of these by a, b, x, all the numerators are 1, right? So it would be the same thing over each of these. Now let's simplify where we can. So my a's would cancel out here, my b's would cancel out, and my x's would cancel out. So I would be left with bx plus ax equals ab. Now remember, you were trying to isolate the x. So what do both of these have in common? They have an x in common. So if I factor out an x from this first part of the equation, I'm left with b plus a. Now the only thing that I have to do, if x is being multiplied by b plus a, if I divide both sides by b plus a, the x is isolated, so it would just be x equals ab over b plus a. That is my answer, because I know I'm done because x is isolated for. All right, you try one. So you're going to solve this for x. You should have gotten that there is no solution, because if you solve this by multiplying by the LCD, which is x minus 7, you would get that x equals 7. But if you look in the problem right here, if I plug in a 7, that would give me a denominator of 0, which can't happen. So it's no solution. All right, so we're going to practice one more. This is really easy. I'm going to solve for the indicated variable. I want you to solve for A. Now this is force equals mass times acceleration. You're going to be using this in physical science. So say we wanted to solve for acceleration, you would just divide both sides by the mass. So acceleration equals force over mass. I just wanted to show you how that works with a physical science problem. So here are some extra practice problems I want you to try. So go ahead and pause, and I'm going to give you the answers in a little bit. Okay, and then those are your answers. So if you need any help, just let me know. I know I've got this when I can solve equations containing rational expressions and solve equations containing rational expressions for a specified variable. Do you really understand? So explain how to use the multiplication property of equality to clear the fractions from an equation such as the one below, and then show the result of this first step. So the first step would be to multiply both sides of the equation by the least common denominator, and then that is what you would get if you did. Actually, if I multiply both sides by the least common denominator, I would get, I would multiply both sides by x minus 2. So I'd actually get this if I did that, and I would get 2 equals 2, which is all reals. So that would mean that anything would work in that equation.